Alright, so for this group of questions, we're going to base our answers on the velocity versus time graph that they gave us. 63, determine the magnitude of the average velocity of the car from 6 to 10 seconds. Now for this one, just be careful when you read it. It's a velocity versus time graph, which is always important to note on, right? What type of graph is this? And what's the problem asking for? It's asking for the average velocity. And so the way you can kind of think of this is, well, at 6 seconds the velocity is 15, at 7 seconds the velocity is 15, at 8 seconds the velocity is 15, all the way through 10 seconds. So what's the average velocity for this time interval? It must be 15 meters per second. And that's our answer. 64. Determine the magnitude of the car's acceleration during the first 6 seconds. So 64, a couple ways you can do this. One way that you can do that was you say, all right, we're looking at the acceleration. What's the equation we know for acceleration? How about A equals delta V over T? During this first 6 seconds, it goes from 0 to 15 meters per second. So what's the change in velocity? 15 meters per second. What's the time it takes from 0 to 6 seconds? 6 seconds. 15 over 6 gives you a value of 2.5 meters per second squared. And that's our acceleration. You could have gotten the same answer from doing the slope of this, the slope of the graph during this time interval. Rise over run, or change in y over change in x, you would have plugged in the same values and gotten the same answer, 2.5 meters per second squared. And then if we look at number 65, identify the physical quantity represented by the shaded area on the graph. So if you know this one right away, you can definitely stick with it. But if you remember that trick we had from towards the beginning of the year, the GVA trick, remember if you go towards the right, you're doing the slope, and if you go towards the left, you're doing the area. So this is a velocity versus time graph. We're starting at the V, and we're taking the area. If we go in this direction, where do we wind up? At D. So this is a displacement graph. And that is our answer to 65.